Section 7.4, we are establishing trig identities and using the identities that we are familiar with. Starting with problem 26, we were doing problem 24 in class, but so I want to start with 26 first and then ask you to perhaps pause the video and try number 24 on your own. Some students had trouble in class establishing the identity here at number 24. So anyway, let me just walk you through 26. Now, if you remember the steps for establishing identities, just put a box around one side. Typically, one side of the equation. Typically, you're going to not touch the less complicated side of the equation. And that's what I wrote here, like don't touch. So you're going to leave that alone, and all you're going to do is you're going to manipulate the left side of the equation here to make until it looks like the right side. And so we'll just go ahead and get started. Sine of u times cosecant of u. One of the main strategies with simplifying the left side would be to change all of the trig functions to sine and cosine. And we see that here, cosecant of an angle is equal to 1 over sine. So we're going to replace cosecant with 1 over sine. And we still have that minus cosine squared. And then just using some algebra, sine times 1 over sine is just 1. So we have 1 minus cosine squared of u. And if you look up here at the first Pythagorean identity, sine squared plus cosine squared equals 1, if we solve for sine squared, that's why I left a little space down here. If we solve for sine squared by subtracting cosine squared from both sides, then we get to use that identity, but not exactly the way it looks. Sorry for the flickering light there. But notice that when we subtract cosine squared from both sides, we get sine squared equals 1 minus cosine squared. So we will just replace 1 minus cosine squared of u with sine squared of u, and now the left side looks just like the right side, and we just leave a check right there. Alright, so now just seeing that we can use a Pythagorean identity not exactly the way it looks, but by subtracting something from both sides and by I guess just manipulating an equation here by subtracting or whatever we need to do so that we can use a substitution in our exercises over here on the left, then that should help you with problem number 24. So let's go ahead and maybe see if you can pause the video and try number 24 on your own and get that right. And what you should have done to be successful in this one, first of all, put a box around that one, don't touch. Sine of theta, and then again, like I said, we typically a good rule of thumb is to change every one of the trig equations, every one of the trig functions to sine or cosine, or both. Now the cotangent of theta, scoot that down a little bit, cotangent of theta is cosine over sine. So we have cosine theta over sine of theta, and then the tangent of theta is sine over cosine. So then, using a little bit of algebra, we're going to just go ahead and distribute the sine theta to both terms. So we have sine theta times cosine theta sine theta, okay, plus the sine of theta, plus the sine of theta times sine theta over cosine theta. Okay, so what do we have? We have the ability to cancel those signs, and so we have cosine theta plus sine theta times sine theta is sine squared theta over cosine theta. Now, when we get all of the trig functions in terms of just cosine and sine, sometimes it's easier to do this. To just write C for cosine theta and S for sine theta. And then sometimes that would trigger, oh, wait a second, I have to get a common denominator. And a common denominator here would be multiply top and bottom by cosine, by C. And so if we add these two together, we get c times c is c squared plus sine squared all over cosine. All right, so that's when we add fractions. Let's say we have 2 plus 1/5. Okay, 2 plus 1/5. Well, if we want to add those together, we're going to multiply the first fraction or first number by 5 over 5, and we get 10 over 5 plus 1 over 5, and that's just 10 plus 1 over 5, or 11 over 5. So that's just, again, going back and back and back until we can recognize that we just can treat these trig functions just the same way we would treat a regular number or a regular variable. And we're going to use algebra, and that's the biggest thing in this section, is we're using algebraic strategies or steps. Just we're simplifying these expressions algebraically. And so anyway, once we get to here, and let me show you what it looks like in real time. If we just write cosine every time instead of just c every time, we're going to have cosine squared of theta plus the sine squared of theta all over cosine theta. Well, if you look up here, we've got sine squared plus cosine squared equals 1. So every time we see a cosine squared plus sine squared, we're going to just replace that with 1, and that is 1 over cosine theta. And if you look back up at the box, what we put in a box, we're supposed to show that the left side is equal to secant of theta. Well, 1 over cosine of theta is equal to the secant of theta. So check. So you just keep simplifying the left side until it looks like the right side.